Good morning, guys. So today we'll be continuing after projectile motion, and we will finish the chapter today. Okay, after that we will do some of the NCERT problems, which I believe you will be finding difficult if I send you. Of course, I will be sending you the link of the YouTube videos where these NCERT solutions are there, so that it will be helping out. But I will do a little bit questions along with it. Okay, after that, the next 45-minute session we will have purely entrance questions. Okay, now let's start with the topic, which is the last topic of motion in two dimension, which is circular motion. Circular motion. If someone asks you whether a circular motion is at one dimension and two dimension, of course it is two dimension motion. See, this is a circular motion, right? When you consider this point, let's say you are taking the axis like this, right? So this point is having both x value and y value, right? So circular motion is a two dimension motion, right? So what is the property, or what is the speciality of a body which undergoes a circular motion? When a body is moving in a circular path, it will be having usually a uniform velocity in a particular direction, right? If this is the path I meant to draw a circle, I think we will have a circle here. Let's see. No, no. Here, forgot the, yeah, we have a circle. Wow. So this is a circle, guys, right? So when, and let's say this is the path which is taken by a car, right? It is undergoing the circular motion in this direction, let's say, right? So it is usually, it is in order to have the same circular motion, it has to, or circular path, it has to have uniform velocity, or I can say constant velocity, right? Yeah. Now let us consider here itself. Let us consider in the circle. I don't want to draw another circle. In this circle, there is a body B, right? Let's say this is a body B, and it is moving. This path, or the circle which I have drawn, is a circular path of this object B, right? Now let's this be its initial position B1, right? Then its position has changed to P2 after travel for a time, right? So that means it is just, okay, circular path means it will be having a center. Say that is a center, right? So I can draw it like this, right? So similarly, if there is a stone, I tie with a thread and I revolve it like this, then this path is also circular motion, right? I hope you understood. This is the radius, right? Now P1 and P2 are the initial and the final position of object B. Clear? Now velocity at point, any point, how can I say about it? We have learned in our earlier chapter how the velocity is drawn. Remember? If not, listen to it. This is the position P1, I believe. This is position P2. Right? Oh, I have to bring it this down. Right. At P1, I will draw a tangent, right? Velocity at a point is along the tangent at that point, right? So this is a velocity, let's say V1, right? Similarly, there is a point P2. If I want to find the velocity here, I have to draw a tangent in the same direction as that of the path. So the velocity will be V2 in this direction. Right. Now someone asks you, found the direction of velocity, very good. Now someone asks you what will be the acceleration of this path, or acceleration of this object which was undergoing a circular motion. How would you find it? So acceleration has the same direction of change in velocity. Remember, I taught it. So what is change in velocity? V2 minus V1. That is, I have to write it as actually V2 plus minus V1. That will be, do it figurally. I have taught you guys. So V2 is in this direction. I will take like this, V2. Then I have to reverse V1, so that this, ouch, reverse V1 means this will be the direction, right? So this becomes minus V1. Now this section, Which one? This one, right? If I take that direction, that is this continues this direction, this will be delta V. I have told about the triangular method. You guys can draw it by yourself. So if I consider this, that means just take the direction of delta V. You will see it is in this direction, right? Same, right? So I can say delta V is towards the center of the circle. So that means acceleration is towards the center of circle. And this acceleration which is towards the center of the circle or motion, that is known as centripetal acceleration. Centripetal acceleration. Clear? Now this much is clear. Now we'll go with what is magnitude of acceleration. You know the direction of acceleration is always towards the center of the acceleration. Oh, sorry, circular motion center. Again, I require a circle. Oh, I don't know why. Ouch. Bring it here. Now let's bring it here. I have to bring the entire sheet down. Then I will bring this one here. This much is real. Okay. Okay. Now here again in this circle, see, we initially had a position P1, remember? We had a position P2 here, right? And how did we draw the velocity here? And this is, let's say, V, and let's say this is P dash, right? Velocity at P1 and velocity at P2, and this is the center. We drew two position vectors. Let's say this is R vector here from O to P1 and O to P2, let's say it is R dash vector. Clear? Simple, right? Now what will be the direction of delta? This one, right? This is OP, OP2, right? So I hope you understood this is delta R. Clear? Now oh sorry, P1 to P2. Now if again the same process which we did in the earlier section we are going to do, because just to confirm. Okay, now here I am going to draw the direction of V dash. What is average acceleration? The same direction as delta V, that is V2 minus V1, right? Similarly, I'm just drawing a line, guys. It's okay. You will understand why I'm doing it. Right. So what is V1's direction, or V dash direction? Say this one. This is V dash. And what is the V direction? Minus V direction, right? This will be in this direction, opposite, right? So this, along this line, I will darken it. This is our resultant delta V, right, which is V dash minus V, right? And delta V is the acceleration. So you exactly got the acceleration towards the center. This is the exact same figure which is there in your textbook. Okay, now there are two triangles, right? You are having triangle O, then this one O, P1, P2, and you are having a triangle, let's say this one as A, B, C. Now these two triangles are similar. These two triangles are similar, I hope you understood. Right, if these two triangles are similar because they are made up of same type of components, R dash is similar to V because it is parallel to V. Similarly, R vector is parallel to V dash vector, so they are similar, right? So I can say, you can take the ratio here, delta V of this triangle, delta V by V, right? Delta V by V will be equal to delta R by R. Clear? So I can write delta here. What is the radius? Let's say radius of the circle is capital R. So delta R by capital R, right? That is the R vector here. Let's say that as capital R. So I can write delta V is equal to V into delta R by R, right? Yeah. Now if you are asked ratio or you can just you need not write the delta r section, you just have to write delta v by v is equal to delta r by r. Keep it as it is, no need to no change the order, because the next topic is not, this is not what we want to find. We want to find what is acceleration's magnitude, right? So we know acceleration is, or instantaneous acceleration is when delta time tends to 0, when delta v by delta t, change in velocity by time, when time approaches 0, or usually write it as dv by dt. Remember, right? Now here we require limit delta t tends to 0 equation. Limit delta t tends to 0. In place of delta v, right? I hope you understood why I told you to rearrange it. It's okay if you didn't. Delta v is equal to v into delta r by capital R whole divided by delta t, right? Right. So this one I can write limit delta t tends to 0 is equal to v delta r by capital R delta t. Right. Out of this, v by r is a constant term. Sorry, this is into, right? I wrote equal. Limit. Alright. Let's bring the constant terms outside. V by r is constant. So limit delta t tends to 0 delta r by delta t. Now what is this term? When limit t tends to 0, rate of change of displacement by time, that is our velocity, right? R I can write it as what? dr by dt, right? Clear? Now this is magnitude of acceleration which we are finding here. Now v by r, what is dr by dt? Rate of change of displacement by time, it is our velocity. So I can write v squared by r. That is, here I am going to write the centripetal acceleration, because we are finding the magnitude of centripetal acceleration is equal to v squared by r. This is very important equation, guys. Clear? Now the next term which you have to learn is angular velocity. Right. Now angular velocity symbol is omega. Okay, keep that in mind. Now what is the definition? It is the rate of change of angular displacement with time. So when this definition comes out, you will ask what is angular displacement, right? Simply this is just like this. Again I will take a circle, right? This is a circular motion condition I am going to take. This is the initial position, say P1, this is the final position P2. Let's say this is the center O, right? We drew two vectors like this, or I can say from P1 to P2, right? A vehicle travels, right? So he is having a linear displacement in this part of the circumference, right, of the circle, right? Along with it, the person who is traveling from the P1 to P2 is also sweeping an angle, say delta theta, right? He is sweeping an angle right here, right? This angle delta theta, or you can even say it as just theta itself, is called angular displacement. It's called angular displacement. I take it as delta, right? So this is delta, right? The angle which is swept by a body which is undergoing a circular motion from one point to another point, or from one position to another position, is known as angular displacement. Okay, clear? So I just told you what is angular velocity, rate of change of displacement. Now you can write it as delta, no? Right? It's better you take angular displacement as theta itself. So rate of change of displacement, I will write it as delta theta divided by delta t. That is rate of change of displacement, right? Clear? So this equation is also very important. Omega is equal to delta theta by t. Clear? Now if you are asked what is the relationship between linear velocity and angular, linear velocity means it comes in straight motion section, whereas omega comes in circular motion, right? Both are velocities, right? One is in meter per second, omega is usually in radians per second unit. Okay, keep that in mind. So we will find how will we find the relationship, right? Again we require a circle, guys. let me drop here. So let's say this P1 is the initial point, the P2 is the initial point. Let's say it is sweeping an angle delta theta. Yeah, let's say its initial to final position displacement is delta r, capital R is the radius of the circle, right? Now we know what is the linear velocity. Linear velocity is delta r by delta t, displacement by time, right? Change in displacement by change in time, right? Now from this figure, delta r is our arc length. It's an arc length, right? And we know arc length is equal to radius, right, into the angle which is delta theta, right? Now let's say we are going to divide delta t throughout, right? Now what is delta r by delta t? We just wrote it as what? Linear velocity, right? And that what is delta theta by delta t? That is omega. So v is equal to r omega is the relationship between a linear velocity and angular velocity. That is, if you want to find angular velocity of a circular motion and you are given the linear velocity of the ball, you just have to multiply it with omega. Clear? Sorry. Now, I can, depending upon this equation, I can even change our centripetal acceleration, which is v squared by r. Remember, in place of v, I am going to write r squared omega squared by r, or I can write, one r cuts off, right? Omega squared r, or I can just write r omega squared. This is another expression for centripetal acceleration, right? Similarly, our theory is going to finish up, guys. Suppose you are asked what is frequency of a circular motion. Frequency is the number of times, or before that we will talk about time period, right? Then only it is better to talk about frequency. Now what is time period? Time required for one complete circular motion, right? Time required for, and this is represented by capital T. Frequency is usually mu or f, both are correct, right? So time period is the time which is required for one complete circular motion. Frequency is number of circular motion is happening in 1 second. How many number of oscillations, or it is usually circular motion happening in 1 second. Is much clear? Now we just have to know there is a relationship between frequency and time period. I believe you know, is f is equal to 1 by t. Keep that in mind, guys. We just found then velocity, right, is distance by time, right? So suppose for one circle I consider how much is the distance it is traveling. Don't take the displacement, guys. Take this as a speed condition. It was what? 2 pi r, the circumference. Let's say radius is capital R. So divided by t, or I can write it as 2 pi r f. But 1 by t, right? So I will write it as 2 pi r f, right? And so there is an expression for linear velocity like that. Now omega, that is angular velocity, is the rate of change of displacement with respect to time, right? So here what is the angle change for one circle? 360 degree, or I will write it as 2 pi, right? And delta t is total time is t, so I can write it as 2 pi f. Clear? So I hope you understood. So v can be written as 2 pi r f, omega can be written as 2 pi f. Clear? By this we are completely finished the theory portion of the motion and plane class. I told you before in the starting of the video that we will be now doing a little bit of numerical questions in the NCERT solution side, right? NCERT textbook, sorry. So we'll start with the 13th question. Previous question, see, 12th one is something which you have done in the live class, so you guys can do it by yourself. It's not a big deal, right? So next question is this one, right? A man can swim with a speed of 4 km/h in still water. How long does it take to cross a river of 1 kilometer wide if the river flows steadily at 3 km/h and he makes his strokes normal to the river current? How far down the river does he go when he reaches the bank? I hope you didn't understand anything, right? So you are told, take a look. This is the river. It is 1 kilometer wide. There's a person here, let's say here, and he wants to reach, this person want to reach here, let's say A, just purple, he is going to swim in this direction. And I told you, and it is told that there is a river which is having the velocity of what, 3 kilometer per hour in this direction. Now if he goes in this direction, will he reach A from, let's say, O? No, he will reach here somewhere beyond it, right? Logical section, right? So now we are told he is going to move in this direction, that is his wish, right? So let's name some of the things, right? Then we will write the terms vectorial as well as, and how it can be solved by just graphical, I will tell you, right? Now let's say there is a person here in the ground, he is viewing the swimmer try to swim, right? The swimmer, suppose as per him, is going to swim in this direction, right? So let's say in the river there is another person. For him, he will see in which direction this person is drawing or the swimmer is going. For this person, obviously for him this will be a straight line. Just think in this perspective. For him, the swimmer will be in the direct direction only, because he don't see this end nor he sees this end, he will just see the path, right? For him this will be a straight line. Clear? Right. Now suppose, okay, I will take another color to draw the directions, guys. So this, let's say, is the velocity in the, okay, before that, suppose I told you a person here standing will be feeling him to a straight line, right? Suppose in place of that person I just consider it's a particle of river itself. So this water molecule, let's say, for him this will be the straight line or the path of the swimmer, right? So in place here, the name of this vector I am going to give it as V, velocity of R with respect to, sorry, velocity of swimmer, right? As swimmer's velocity is seen like this, right? So velocity of swimmer with respect to river. Clear? Right. Now, so at him there is a velocity in this direction also, that is a velocity of river. With whose perspective? The person in the ground, right? Clear? Now the person in the ground will feel that he is not reaching A but at B. That means he traces the path of the man or the swimmer like this. So I will name it as VSG. Clear? Now what is the velocity of river? It is 3 kilometer per hour. And what will be the swimmer's, right? Swimmer's speed with respect to straight. He wishes to draw in straight line, right? So obviously it will be 4 kilometer per hour. Right? So actually we can take it as a resultant. What will be the velocity of the person with respect to ground? It is a resultant of 4 and 3. I can just write it as 4 square plus 3 square like this, and I will find the value as 5. Right? But how would I write it, or how would we understand it vectorially? So VSR, velocity of the swimmer with respect to river, is VSG minus VRG. Right? Now what is VSR? VSR, 4 in upward direction, I will write it as what? 4J vector. Right? Clear? That is equal to, I believe it is, the river is having the speed of 3 itself, right? Right. So it's correct. Right. It is a swimmer's speed is 4 kilometer per hour. Right. Then it is correct. And what is VSG? We don't know. That is what we have to find. Minus 3, what is velocity of the river with respect to ground, y in x direction. So it is I cap. Right. So I can write VSG is equal to 4. So I can write it as 5I cap plus 4J cap. Right, this is the vectorial representation. Again, I can find the VSG's magnitude by 5. It is 3, na? Sorry. What is the velocity of river with respect to ground? Is 3I. Sorry. Right. So it will be root of 3 square plus 4 square. That will be answer 5. This is how vectorial representation comes up. Now, the bigger thing is, this is not the what the question was. Actually, 2 questions were asked. Right. 2 questions were, if this is the river, right, what by what time he will cross keep in mind the sentences at what time he will, that is in his perspective, in which time will he cross the river. That is, crossing means in which displacement it is, y displacement. That is the first question, right? So how much time he will take to cover y displacement. Clear? Right. Now the second part is, how far down the river does he go when he reaches the other bank? Means how far does he travel from this A position to B? This much. That is, you are asked the displacement x. You are asked time to have the displacement y in the first question. Then you are asked what is the x displacement in this direction. Clear? Right. Now again I'm going to draw a figure. I'm taking a lot of time because I want to make you guys understand the logic of it. Now see guys, this is the river. This person actually moved in this direction, velocity with respect to ground, and he had two components of velocity actually, right? That's how it came. That is, he is influenced by the velocity of himself, that is swimmer, and velocity of the river. With respect to ground, I am not writing it. Clear? Right. So this y displacement, which is 1 kilometer, is done by which velocity of this person? Its vertical component, right? That is, his velocity in this direction is causing y displacement of 1 kilometer, right? Whereas this displacement in which direction, right? In this direction, this is the A position and this is the P position. So this displacement is caused by which velocity component? By the horizontal component, that is VR. Clear? Right? So vertical displacement is caused by vertical velocity component, and horizontal displacement is caused due to horizontal velocity component, right? Now let's say vertical distance, let's say is y, is equal to velocity in y direction into time required by it, right? So I can write time is equal to y displacement divided by velocity in y direction, right? What is y displacement? It is given as 1 kilometer divided by what is the velocity in y direction? It is 4, right? Velocity is in this direction is 4 kilometer. So it will be around 0.25 hours, right? Quarter of the hour, right? Now second question is, what is x amount? That is, displacement is asked. Displacement is vx into t, right? What is the velocity in x direction? That is velocity of river, that is 3. And how much distance he takes to reach the point B? It is actually this much time itself. That is, how much when he is having horizontal direction displacement, at the same time he is having vertical displacement also. So both of them are happening simultaneously, right? So in time place I will write this, I can write this 1 by 4, right? So it will be around 0.75 kilometer, will be 0.75 kilometer. Clear? I hope I have taken it. Actually, I think I have taken a lot of time to make you guys to understand the theory part of it. Clear? I'm going to do this for 4.14 question. This one, because it's a different thing, right? So listen. See, it is asked in this to the store in a harbor. I hope what is a harbor? I know. You know, this is a place where ships come, right? And they sometimes rest, or they have what trading section, etc. can come up. So in a harbor, wind is blowing at a speed of 72 km per hour, and flag on the mast of the boat anchored in the harbor flutters along northwest direction, right? If the boat starts moving at a speed of 51 km per hour to the north, what is the direction of the flag on the mast of the boat? That is, initially there was a wind, right? And now the boat is going to move in the north direction. So due to the wind as well as due to the velocity of the boat, in which direction will be the flag moving? That is simply in the layman language, right? Yeah, that is due to the velocity of wind and due to the velocity of boat, what would be the direction of the flag? It's just like that of our what? Remember, same as that of our what? Our umbrella, but it is a little bit different. Okay, see. Oh, I will take blue color. I don't know why blue color is not getting selected automatically. Now, when the boat is anchored in the harbor, the flag is fluttering along the northeast direction. Now, before taking the section, guys, I will might like to make you remember, guys. There are some questions which is better taken or easily solved by graphical method, because in some of the sections it is difficult, because here see northeast direction etc is given, right? So northeast direction means you will take 45-degree here, right? This will be the direction of our what is the direction of this direction? The flag, right? When the boat is anchored in the boat, the flag is fluttering around the northeast direction, right? So that means now the wind is along the northeast direction. So this is the velocity of wind, right? So this type of graphs is difficult, right? So it is better don't make it into I and J, because there will be a lot of, because this northwest means this will be 45 degrees. So two components, if it is make it is cos 45 degree, what is cos 45 degree? 1 by root 2, complex thing, right? So calculation will be very difficult, right? So this type of question it is better if we are able to solve by pictorial representation. Happy, right? So now what was it all? So this is the direction of wind, right? So because first the boat was not moving, so if the flag has fluttered, because it is only due to the wind. So this is the direction of wind. Clear? Now when the boat starts moving, now the flag will flutter along the direction of the relative velocity of the wind with respect to boat. That is velocity of the wind with respect to boat. If that is the direction by which he or the flag will move. Yeah. Okay. Suppose, and you are told in which direction? North direction, right? In north direction the boat is going to move. So this is the boat's velocity. Let's name it as pb, right? And you are asked what this one, right? So how would you write this one? VWV, that is velocity of wind minus velocity of what? Boat, right? We are not writing ground, okay? It's okay, I hope you understand. It's actually with respect to ground itself. So VW plus minus VB, right? This is the meaning. That means I have to now make this is, that is VWB is the vector sum of, right, VW, that is this one, ouch, I hope you understood, and what? Minus VB, so this is minus VB. Clear? So what will be the resultant? The resultant will be between them, right? Clear? Right? And what is, okay, let's take the magnitude now. What is the magnitude of wind now? 72 km per hour, right? What is the magnitude of minus VB? It will be, how much is given? 51 km per hour is given. Clear? Now let us take some of the angle, guys, right? Right? This much clear? Now what will be the angle between this and this? There is 45 here, there is 90 here, so this entire angle, if I mark, it will be 135 degree, right? 90 plus 45, right? So that is angle between the two vectors. These are the two vectors and I want to find the resultant of it, right? So let's say the resultant obviously will be between here, right? Let's say this is the resultant, that is VWB, right? And what is the theta? That is the theta is the angle between the vectors. We have found it as 135. Clear? So you are asked, have redrawn the figure because I want to measure, give some of the help for you guys. So I hope you understood. This is 45 degree. Let's say the beta is the angle which the resultant is making with the wind, because that is the boss, right? Now you have two values, right? So I hope you have remember if there is two vector like this is P, this is Q, and there is a resultant like this, right? And resultant is making a vector beta from here, means I can write tan beta, right, is equal to sorry, here P sin theta divided by Q plus P cos theta. There is a formula like this, remember. Clear? Right? And I think I have took it. If not, please keep that in mind, right? Now that means I can write tan beta here, right? What is tan beta? It is P sin theta here. So here P sine theta is this one, P. That is P is 51 sine theta. That is sine theta becomes what? I have found it as what? 135 degree, 45 degree, right? This is 45 degree plus 90 degree, this one. This is 90 degree, so it becomes 135 degree divided by, right? In place of Q, I will write as 72 because I am finding the angle with that one, with wind, plus 51 cos 135 degree. Right, now this is something which is trigonometry. So tan beta is equal to 51 sine 135 is sine 90 plus theta, which is sine theta, which is sine 45 degree. 72 plus 51 cos 135 is cos 90 plus 45 degree, that is minus cos theta, that is minus cos 45 degree. Right, now put the values guys. 51 sine 45 is 1 by root 2, 72 plus 51 minus 1 by root 2, right? So you will get the value of around 1, not a 1, it is more than 1, it will be around 1.0039 something, right? So that means beta is tan inverse this value, which is close to 1 but greater than 1. Now that means if tan inverse 1, it was asked, you could have written 45 degree. So the angle is definitely greater than 45 degree. Let's say it is 45.1, right? Let's move on to the diagram guys, because it is very important to understand. That means I have taken another color, right? This angle is what, which we have found 45.1. This angle is 45, right? That means you are asked what is the angle made by the resultant, right? The wind, or the angle made by the flag actually. So you have to find this one. So that means from here, if I remove this one, I can get this one. That is when I remove 45.1 degree, from that I remove 45 degree, you will get 0.1 degree, right? So this value is 0.1 degree. So that means the flag is trying to move towards east in which angle? 0.1 degree, which will, it will flutter almost due east. Clear? Question we are going to deal with, let's say, is 4.15. Right, the ceiling of a long hall is 25 meter high. That means that is the maximum height. What is the maximum horizontal distance that the ball thrown with a speed of, that is initial velocity, can go without hitting the ceiling of, that is, this ceiling is 5 meter high. You are going to throw the ball with 40 meter per second, and it shouldn't, that ball shouldn't touch the 24 meter height, means the maximum possible height it can achieve is 25 meter. Clear? Keep that in mind guys. I'm going to shift it here. So what all is given, maximum height I am going to write h max is given as 25 meter. You are actually asked what is the horizontal range, right? Suppose this is the okay, sorry, ceiling, right? I threw a ball like this and it has to write like this, and that means you are asked what is this distance. This is the maximum distance which can be achieved. It shouldn't touch. It's the maximum height it can achieve is 25 meter, and the initial velocity of projection is given as 40 meter per second. So you are just asked what is range. So what is the range equation? Before that we can use what? Horizontal, right? Given, because you don't know with which angle it is projected. So I have to use that one. H max is equal to, what is the horizontal sections? U squared sine squared theta by 2g, right? Now what is the maximum height given? It is given as 25 meter, right? So from here this equation I can write sine squared theta is equal to h max into 2g divided by u square, right? So h max is 25 meter, 2 into 10, what is velocity square? 40 into 40, right? Clear? Now calculate this value, you will get around how much? 10 cancels out, right? Then 25 cancels out with 8, right? Then 4, right? So you get around 5 by 16, right? You get it as around 5 by 16, I think so. So it will be very close to 0.3 something, right? So 0.3 is the sine square theta. So sine theta will be root of this 0.30 something, right? Yeah, so that means, see guys, this and all values will be given. So I have used a calculator, right? So you will get sine theta, sorry, sine this value as 0.5534. So in your examination, obviously you will not be allowed to use a calculator, I believe you know, right? So that time, then in bracket, this will value will be given, that is sine, or this angle is this one, this angle is, or this one, etc. will be given, clear? Or root of this value is will be given, right? Right. So now you got a sine theta as 0.5 means around close to 1 by 2. Right. So that means our theta is close to 30 degree. Right. The actual value is 33.6 degree. Right. So that means R is equal to U squared sine 2 theta by G. We just have to substitute here. So it will be what? In place of U squared, I will write 40 into 40. Sine 2 theta is sine, and double of this value will be around 67.2 whole divided by 9.8 or 10 you can take, right? You will get around 150 meter, not the exact value guys, 150 meter, clear? Right. So going to the problem, this is a part of a problem guys, but we will not have the time. If possible, I will try to do this problem in the next class, but before that I want to make the section, suppose clear. Suppose, ouch, I again selected black, huh? There is a vector A, right? Let's say that vector is 2i. This is a question in your textbook itself, but I am not telling you which one, right? And there is a vector called r1, right? It is I plus j, right? You are asked the component of vector A along r1. Again, read the question. You are asked what is the component of A vector along r1. You have to find the magnitude as well as direction. Let's see, if I write 2i, or let's say it is ai, it's a value, that means the vector's horizontal component, that is in the x direction, right? For x direction I am writing the unit vector what, I cap, right? So that means there is a value 2i means 2 magnitude in I direction. Yeah, so I gives you the direction. So in place of I am going to substitute which question, as per your question, your direction as asked along I plus j, right? Let's write it again. Suppose you are asked or given a vector 2 I cap, that means magnitude 2 in I direction, 2 j cap, that is magnitude 2 in j direction. So unit vector gives you the direction, keep that in mind. So you are asked what is a vector, right, along r1, that means vector a dot, in place of I and j you have to write what, r cap or r1 cap, right? Clear? So that is vector A along r1. In place of I wrote it as r1. Clear? Similarly, if there is a, you are asked what is the vector A along r2, you will write along vector A into r2 cap, because the direction now is given by r2. Clear? Simple if you understood. Now we will go over the same question guys. So you are asked what is the a along r1, so that is it is a dot r1 vector, right? Sorry, a capital a vector, it is 2i plus 3j, right? What is r cap? Magnitude of r1 vector divided by r1's magnitude, that is 2i dot plus 3j, right? Then r1 vector I will write it as I plus j, right? I plus j, and magnitude is root of I square plus j square, this root 2, 1 square plus 1 square, right? Now calculated 2i into I will be 2, 3 plus 3, 3, that is root 2, you will get 5 by root 2 as magnitude of a vector along r direction or r1 direction, right? Now you are asked even direction also. If you are asked, that means you have to write magnitude into what is the direction, r1 cap, right? That is the direction you are writing. So that means 5 root 2, what is r1 cap? That is I plus j divided by root 2, we just wrote it. So this is the vectorial writing, that is 5 by 2 I plus j cap. Clear? This is this is how you are supposed to attempt this question. Clear? That is, if you are given a vector and you are asked, suppose there is another vector b, you are asked what is the value of vector a, component of vector a in the direction of b, then how would you write? Vector a dot b cap, that is the b cap gives the direction of b. Clear?